This video is about abstract classes made simple. We'll try our best to make the concept of abstract classes as simple as possible by following the following comments. Before we start, let's just sort of emphasize what the word abstract means. It basically means incomplete. So an abstract class is an incomplete class that needs to be completed by its child classes. And the opposite term of abstract is concrete. Concrete means complete classes. So let's have a look at how we could create abstract classes and what characteristics they have. We'll start off by the first comment, where the abstract classes can have instance variables. But first, let's create the abstract class. So here we have a comment saying abstract class representing animals. So I'd like this abstract class to be about animals. So to declare an abstract class is pretty similar to what you do in normal cases, where you create the class. This is how we previously created an concrete classes, complete classes. So if you'd like this class to be abstract, the only thing you need to do is, or the first thing to do is to actually add the keyword abstract. Here we specify, we let Java know that this class is going to be abstract. So let's create private instance variables. And I just want one, and in this instance about an animal, probably the name. Let's have a look at the second characteristics. Abstract classes can have constructors. So let's create a constructor for the animal class, and we would like this to be public and just the name. Here we will initialize the name instance variable to the value we pass through the constructor when we kind of create an object like this. But we'll come to this point, we can't really instantiate an object of this animal class because it's been declared as abstract. But I'm just referring to how this value like this would be passed to the instance variable. The third point is it can have getters and setters. I'm just going to create a getter for the name. We return the name. And fourth point is it can have both abstract, let's make this slightly bigger. It can have both abstract methods. So when we say abstract methods, we know the word abstract means complete, but in this particular instance, we're referring to methods. So this is an incomplete method, as a method without a body. And it can also have concrete methods, where concrete means a method with a body, basically a complete method. So let's come here down all the way and talk about abstract methods to make sound. So this abstract method is pretty much about making the animal itself making sounds. So again, the process of making a method abstract is similar. So in the past, this is how we created methods, but you notice that the compiler is complaining because I have not created a body for this method. So here it's giving me suggestions to either add a body or to change this to an abstract class. And that's exactly what we want. We want this method to be abstract because we don't really know each different animal makes a different sound. So we want this to be an abstract method such that each subclass will make its own unique sound. So here, concrete child classes will implement the abstract class differently. So the minute we make this class abstract, any child classes need to actually implement any abstract features of this class. In this case, it's this method. If the child class does not implement this abstract method, then that child class needs to be abstract. So it only becomes concrete when it implements the full functionality of this method, of this class, sorry. This class is incomplete, it's abstract. So the only way to make this, child classes can only make this class, implement this, to become concrete, they need to implement all of the abstract features of this abstract class. I hope that made sense, but I'll demonstrate it when we are making the child classes, to make it more sort of to make the point more easy to understand. Let's create a concrete method with a body. Now I want to think about it. We want to think of a method that all animals do, so that it's actually a concrete method. They all eat, so that's something all animals sort of have in common. So here we just want to use the instance variable, the name, and is eating. That's pretty much it. So now we've gotten our abstract class. Now, if you look here on the Package Explorer, you can see a little a capital A at the top right corner of this class. This is the compiler realizing this is an abstract class. So to demonstrate, so we've gone through we've gone through number 4. Let's go through 5. Abstract classes are used when you have a base class that provides some common functionality, but each subclass may implement its own specific behavior for certain methods. Now, to demonstrate this point, I'm going to create 2 child classes. I'm going to right-click on the package and go to New, and I'm going to go to Class. And I'll start off with my first class, which is cats. Let's create 2 animals, a cat and a dog. Now let's, I want to sort of emphasize this is going to be a concrete class called cat that's extending the animal class. I can't type. Okay, so to extend the animal class, to extend an abstract class, basically it's the same keyword we use with inheritance, extend, and here we say animal. Now, the minute we extended an abstract class, an animal, we have a compiler here saying implicit super constructor animals defined for default constructor. You must define an explicit constructor. So we can actually let the compiler help us with that. Let's see how it does that. It just adds yeah. So here, it kind of did most of the work for us. That's pretty much what we want. But we still have a problem here. Compiler still complaining the type cat must implement the inherited abstract methods. So we either implement the unimplemented methods, or we make the cat class itself abstract as well. So I'm going to choose the first option to add unimplemented methods. So it kind of figures out the unimplemented methods is whatever has been defined as abstract from the base class or the parent or the abstract class, the animal class, which is to make the sound. So I'm just going to bring this class here. So let's go ahead and override. So to implement an abstract method, we need to override it. So to override it, I'm just going to make this as simple as possible. We would like to use the getter method, the get name, because we don't have access to the instance variable itself. So we can't really, this is private. We can't use it directly. So if I say name, we get issues there. So that's why we've created that getter method, which we can also make protected, but let's just keep going. Okay. Let's say that the cat's sound is meows. Cat meows. All right. So that's our cat class. And again, the minute we remove the implementation of the abstract method, Java is complaining, saying that you cannot choose to make this a concrete class unless it actually completes the work that hasn't been completed by the parent, which it was left intentionally because the parent wanted each child to implement its own behavior in that sense here, its own sound. So they wanted the child to have the freedom of creating its own sound. So the minute I take this off, it's complaining. So the only way to fix this is to either say, this class is also abstract, meaning this cat needs to have child classes to complete the work that hasn't been finished by the grandparent, which said you can have your own sound. Or, which we don't want in this case, I really don't want the cat to be abstract, so I would actually like it to override and complete. Now, the cat class has completed the work of the parent in the sense that the parent wanted it to have that freedom of creating its own sound. So I hope I'm making more sense now. And that's what I was trying to say theoretically, but now we're doing it practically. So in this way, now the cat class is actually concrete. It's complete. Okay, I'll put that in brackets. Now it has completed the work that the parent wanted it to complete. So we've kind of looked at this part is used as a base class that provides some common functionality. So something that's common is that they eat. The child class, all child classes eat. They can all use the get name, but each one of them will have its own sound. What else do we have? That provides, but each subclass may implement its own specific behavior for certain methods. Another freedom that this child class has is to create a method with specific behavior that other child classes might not have. So the cat, the cat has in common. So all animals make sound, but we don't know what sound they make. So that's why we leave it to them to decide. Like in this case, the cat said it meows. But if another specific behavior a cat has, maybe another animal does not have, is climbing trees. So for example, I'm trying to think of an animal that doesn't really climb trees, and I can't think of one. Put it in the comments section. Obviously there are animals that don't climb trees, I just can't think of one. But let's just say that this method is unique to the animal, to the cat. The fish doesn't climb, right? Yeah, so it can't have a method as such. So we can't really have a climbing tree here as an abstract method because not all animals climb trees, right? Like fish, for example, they don't really climb trees. So we won't choose to make that an abstract method. We want to make sure that it's a method that is very generic to all animals. Okay, so yeah, that's pretty much it is for what I wanted to have. Let's have a look at how I might want to make another method, another class to show that this point a bit more clearly. So I'll create another one called dog. Now for the dog, let's make this dog extends the animal. And again, we fall through the same points we have with the previously in the cat class. I let the compiler create the constructors for me, but now for this class, let's just do it ourselves in terms of showing a variety of ways of doing things. Here we call super, we pass name to it, the super constructor. Okay, so the parent constructor. Now again, we either make this abstract or we implement unimplemented methods. Again, let's do this manually. To implement the abstract method, we would override the abstract method. We're using the override annotation. And here we want to use the same signature as this method without the keyword abstract. And now we are going to give it a body, okay? The same way we did for the cat. Here, we're going to use the getter method to get the name of the animal, and we say that the dog barks. All right. Now here we want to create a specific behavior to the dog, so that we can sort of show this point a bit more clearly, the abstract classes is used to have a base class that provides some common functionality between animals, but then each class or each subclass may implement its own specific feature behavior for certain methods. So here, the specific behavior that a dog has is probably fetching a ball. So a lot of animals don't fetch balls. So let's make this sort of unique to the dog. Fetch a ball. Of course, this is an example, and you're free to create your own version of, depending on what you need for your program. Here, we also want to call the getter method, or the name of the dog is fetching a ball. Sorry, not a class, a ball. All right. So now we've created two subclasses. Both of these classes are concrete classes. I'm just going to make this very clear with the comments here. Just changing a few things. Again, at the minute that I stop over, or like say I changed my mind, I didn't want to override the method, then the only way is to actually make this class abstract, which pretty much is not something we want, but just showing you that the minute we make this abstract, it means the dog has to have child classes that complete the work that wasn't completed. Let's undo. Now let's write our driver class. So to demonstrate the usage of abstract class, of the abstract class we created, I have a tester file, a tester class. So let's go ahead and create the object of the cat object. Create that one. So to create the object for the cat, we use the class cat. The reference is cat, same name, but just made it under underscore. See, and we'll give our first cat the name Whiskers. Now, one thing, let's go back to the abstract class. Let's go to the last point here. The abstract class itself cannot be instantiated on its own. For example, we can't really do something like this. I'm just going to copy this and I'll show you how it, I'll paste it there. But it must be subclassed, and its abstract methods must be implemented by its subclasses. So we kind of demonstrate this one. We said that to be using the abstract class, we need to subclasses, and these subclass it, and those subclasses need to actually be concrete classes that implement the abstract methods. Otherwise, if these subclasses do not implement the abstract methods, then they are going to be abstract themselves as well, and until they have grandkids or grandchilds, although subclasses have subclasses of their own that actually complete the abstract classes. So those two subclasses, cat and dog, they are both concrete classes because they've completed the implementation of the abstract method that was defined in the abstract class animal. So we've kind of explained this point, but I would like to demonstrate this point here. So I'm going to go back to the tester, and here we cannot create an object of the animal class like this. So this is actually going to give us a compiler error. When I hover the mouse over it, it says you cannot instantiate the type animal because animal is an abstract class. It's an incomplete class. You cannot instantiate it as below. Okay, so this is our cat object. Let's create the dog object. The dog object is just using the name dog is equal to new dog. I give it a name. Let's give it a name Buddy. Now we can actually start use. So the references here is cat, and the object is also an object of the cat class. The reference in the second object is dog, and it's also an object of dog. So now using the reference of cat, we can call the make sound. This is the abstract method. We can do the same here. Dog dot make sound. Let's run both of them. And so the cat here, the name of the cat, whiskers, it meows, and Buddy barks. So we've actually gotten the name of our objects for the cat from the getName method, which was passed into the superclass for the constructor, assigning that name, the instance variable, the name we've passed it in as an argument here for both of our objects, the cat and the dog. Now we can also call the common method, the concrete, sorry, now we've called the abstract method. We were able to do that because they've been implemented in each of our subclasses here. But now we want to call the concrete method for both objects. Let's see how that works. So cat.eat and dog.eat. Let's see how that works. So the body, where are we? So the meow, Whiskers meows, and Whiskers is eating, the Buddy barks, and the Buddy is eating that. So this is coming in from here. The name is just depending on the object we've created. The other thing that we want to call is those specific methods. So climb tree is only available in cat. So cat.climb tree. And what did we have for the dog? Fetch the ball. So the dog, we can also call that method that is only available in the dog subclass. So now what we have is the cat meows, it's eating and it's climbing a tree. The dog here, Buddy barks, is eating and is fetching a ball. So that's pretty much it for the abstract class. I just want to say one thing though. If you wanted to create if you want to use the animal class as a type of the reference, you can actually do something like this. Animal cat2 is equal to new cat. We'll give it test2, for example. So here, what we can, when we say cat.to, we can access any of the methods that are available in the base class animal, but we won't be able to use the climb tree because this method is only available in the cat class. So it has to actually be an object and a type of the cat class. So keep that in mind if you, unless you want to do a cast. So if you do a cast, that's fine. You make it pretend to be a cat instance at this point, but you can still sort of call the eat method or any methods that are available in the animal class. So yeah, otherwise if you wanted this to be a here, both the reference and the type of the object is cat, so you can access all of the methods that are within the cat class. Where if you've used the animal here as a, so this is different to this part. Here we're only using the animal class as a reference, but the type here is of the cat class. So you can still not do this. You can never do this, but you can use it as a type. So I just wanted to make that clear. And of course, you can also do the same with dog2, new dog, test3, dog2. But again, I can't really do dog2 dot fetch. There's no fetch here. I can't see it. Okay, so keep that in mind. And that's pretty much it about abstract classes. And I'll see you in another video where we talk about interfaces as well. Thank you.